Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in today's video is theorems dealing with parallelograms. This is the part 2 video. In our previous video, we saw 5 of the theorems when the quadrilateral is a parallelogram. Now, the theorems that we are going to discuss in today's video are the converses of the theorem we discussed in our previous video. We can use the following theorems to prove a parallelogram. We will prove a quadrilateral is a parallelogram under the following conditions. Let me list out the 5 conditions. These are the 5 conditions. 2 sets of opposite sides congruent, 2 sets of opposite angles congruent, consecutive angles which are supplementary, diagonals which bisect each other, 1 set of opposite sides which are both congruent and parallel. When these conditions are given, you can prove a parallelogram is a quadrilateral is a parallelogram easily. Okay, let us see the theorem one by one. Theorem 1 states that if a quadrilateral has 2 sets of opposite sides congruent, then it is a parallelogram. So under this condition, let us prove a quadrilateral is a parallelogram. Let me draw the quadrilateral on the board, also with the diagonal. Here is a figure of a quadrilateral. From this figure you can take down the given information. The given information says that AD is congruent to BC and AB is congruent to DC. Now you have to prove that ABCD is a quadrilateral. Has 2 sets of opposite sides congruent, then it is a parallelogram. Okay, let us start with the solution using statement reasons method. We can prove this theorem by using statement reason method. As I said in the earlier video, you always have to prove a theorem using a statement reason method, and you have to start from the given information and then you have to move towards the proof step by step. So what is the given information here? From the figure you can say that AD, BC are congruent, AB, DC are congruent. Please look at the figure. ABCD, a diagonal is being drawn, AC. Once you draw the diagonal, the quadrilateral will be divided into 2 equal triangles. Am I right? It just looks like a 2 triangles placed one above the other. So you can say that AC is common for the triangle ADC and AC is common for the triangle ABC. So this is the same side for both the triangles. Then you can say that AC for the triangle 1 is congruent to AC for the triangle 2. So this is called reflexive property. Please note that from the given information we said that 2 of these sides are congruent, and we then proved by reflexive property the third side is also congruent. S, yes, yes. So side, side, side. By the postulate of side, 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 we can say that the triangle ACD is congruent to triangle CAB. Do you know about Sss Postulate? Yes. If 3 angles of one triangle are congruent to the corresponding parts of another triangle, then we can say that both the triangles are congruent. Okay, so that is our third statement. So far we proved that this triangle is congruent to this triangle. So what will happen? Angle 1 is congruent to angle 4. Same way, angle 2 is congruent to angle 3. We know that corresponding parts of congruent triangles are congruent. In short, we say it as CPCTC. Now we are going to use one property of parallel lines cut by a transversal. If 2 parallel lines are cut by a transversal and the alternate interior angles are congruent and the lines are parallel, am I right? So using that reason, we are going to say that AB is parallel to CD and AD parallel to BC. So the figure has 2 sets of parallel lines. Am I right? So you can say that ABCD is a quadrilateral. So a parallelogram is a quadrilateral with 2 pair of opposite sides parallel. That's it for theorem 1. Hope you're clear with this one. Okay, now let us move on to the theorem number 2. Second theorem states that if a quadrilateral has 2 sets of opposite angles congruent, then it is a parallelogram. Okay, what are the opposite angles in this figure? AC, BD. Okay, the given condition is two sets of opposite angles congruent. Using this information, you have to prove that the quadrilateral is a parallelogram. Okay, as usual, you are going to start from the given information and prove that ABCD is a parallelogram. Okay, what is the meaning of congruent angles? Congruent angles have equal measures, am I right? So the measure of angle A will be equal to measure of angle C. Same way, measure of angle B will be equal to measure of angle D. Do you agree with me? Here we are going to use one of the important property of a quadrilateral. In a quadrilateral, we just have 4 angles. If you add all the 4 corners, you will be getting the total 360 degrees. Am I right? The angle sum property. So you can say that angle A, measure of angle A plus measure of angle B plus measure of angle C plus measure of angle D. Totally, it will be equal to 360 degrees. Now, let us use substitution method here. We can substitute statement 2 in statement 3. You can say that angle A is equal to angle C. Angle B is equal to angle D. So you can substitute this information in this equation. So you can rewrite this as, I'm going to change C and D as A and B. Hope you're clear with step 4. Okay, now you can add the like terms. In the first equation you will be getting 2A's and 2B's. Same way, 2A's and 2D's. So by addition property, I'm going to take a algebraic step here. 2 is the common factor for these two terms. If I take it out and divide the entire equation by 2, I'll be getting measure of angle A plus measure of angle B equal to 360 by 2 is 180. Same way, if I divide the second equation throughout by 2, I'll be getting measure of angle A plus measure of angle D equal to 180 degrees. So by division property, when two angles added and it will be equal to 180 degrees, what does that mean? Yes, the angles are supplementary. So angle A is supplementary, angle A and B are supplementary, angle A and D are supplementary. Because supplementary angles are two angles, the sum of whose measures is 180 degrees. So that is our statement number 7. If two lines are cut by a transversal and the interior angles on the same side of the transversal are supplementary, so the lines are parallel. AB is parallel to CD, AD is parallel to BC. So let me write the statement number 8. We started with two opposite sides are congruent and two opposite angles are congruent and proved that two opposite sides are congruent. So obviously this is a quadrilateral. I mean a parallelogram. Quadrilateral and parallelogram. A parallelogram is a quadrilateral with two pair of opposite sides parallel. Hope you're clear with this theorem. Okay, now let's move on to the next theorem. You're going to prove the quadrilateral is a parallelogram under the condition diagonals bisect each other. Here is the statement of the next theorem. If a quadrilateral has diagonals that bisect each other, then the quadrilateral is a parallelogram. I have drawn two diagonals, AC and BD, and the angles are 1, 2 and 3 and 4. DB bisects AC. AC bisects DB. So under this condition, you have to prove that the quadrilateral is a parallelogram. Diagonals bisects each other. This is the given information. Now bisector of a segment forms two congruent segments. Am I right? So the half of DB is divided into two equal halves, DE, BE. AC is divided into two equal halves, AE, CE. So these two segments are congruent. We know that vertical angles are congruent. 1 and 2 are vertical angles, 3 and 4 are the other vertical angles. So you have proved two of the sides and two of the angles. So you can say that by Sss property, side angle side, if two sides and the included angle of one triangle are congruent to the corresponding parts of the other, then the triangles are congruent. So you can say that AEB, the triangle AEB is congruent to CED. Same way, triangle DEA is congruent to BEC. So by corresponding parts of congruent triangles or congruent property, you can say that AB is congruent to CD, AD is congruent to BC. We proved that opposite sides are congruent. So if a quadrilateral that has its opposite sides congruent, we can say that the quadrilateral is a parallelogram. Hence the theorem. Hope you're clear with this theorem. Next theorem is we are going to prove the quadrilateral is a parallelogram which has one pair of opposite sides, both parallel and congruent. Here is the next theorem. It states that if a quadrilateral has one pair of opposite sides both parallel and congruent, then it is a parallelogram. So we are given that DC is congruent to AB. DC is parallel to AB, both parallel and congruent. Then we are going to prove that ABCD quadrilateral is a parallelogram. AC is common for both the triangles ADC, ABC. So AC is congruent to AC by reflexive property. We know that if two parallel lines are cut by a transversal, the alternate interior angles are all congruent. So what are the alternate interior angles here? Angle DCA and CAB. So angle DCA is congruent to CAB. So far we got one of the side, the other side and one angle are congruent. So by side angle side property. What is side angle side property? If two sides and the included angle of one triangle are congruent to the corresponding parts of the other triangle, then we can say that both the triangles are congruent. So what will happen if corresponding parts of congruent triangles are congruent? Yes, the opposite sides will be congruent. So the opposite side AB and CB will be congruent here. So if a quadrilateral which has its opposite sides congruent, what do we say? Yes, the quadrilateral is a parallelogram. So ABCD is a parallelogram. Hence the theorem. So for proving the theorem, start from the given information, mention the statement and the proofs, that the properties that you are using then and there. You have to write the proof in the statement reason method. Hope you are clear with all the theorems we discussed in today's video. Okay. In case if you get any query or doubt, you can let me know. And in case if you want any topic as a video, please let me know. See you in the next video. Have a great time ahead.